middle of an AI revolution. Tools by Khan Academy, Shopify, Snapchat, Duolingo, Instacart, Expedia, Kayak, and so much more were built with ChatGPT. ChatGPT is taking the world by storm.
ChatGPT.
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 ChatGPT's new update.
ChatGPT.
Powered by OpenAI, everybody is talking about how ChatGPT is going to take over the world. It has truly transformed how we interact with artificial intelligence in our daily lives. Now, we've heard about how amazing it is, but we've also heard about how
not so amazing it is.
This intelligent chatbot can write poems, solve complex problems, and even mimic human conversations with this crazy degree of accuracy. So today, we're going to explore the cutting-edge technology that makes ChatGPT possible. I'll also walk you through how I'm creating a chatbot for new moms on their postpartum journey with the potential of becoming this super insane digital companion for new moms and spreading awareness on problems like postpartum depression or even postpartum psychosis. Central to GPT 3.5, it is its transformer architecture, this groundbreaking advancement in machine learning. So unlike the earlier models that process text sequentially, transformers process multiple words simultaneously. This parallel processing allows for this more holistic understanding of language context. But how exactly does this work? Transformers use what is known as attention mechanisms. These mechanisms enable the model to weigh the significance of each word in a sentence in relation to the others, kind of like how we focus on specific words to derive meaning in a conversation. The transformer consists of two primary components, the encoder and the decoder. But GPT 3.5, being a language generation model, primarily uses the decoder component. Each transformer block in the decoder consists of several layers, including something that's known as self-attention layers and fully connected neural networks. The self-attention layers help the model to focus on different parts of the input text, understanding the context, as well as these different nuances. The neural networks then process this information, determining the relationship and the patterns in the text. Essentially, the self-attention mechanism in the transformers allows GPT to determine which parts of a sentence are most important in relation to each other. For instance, in a more complex query or question, the model can discern the primary subject, identify related concepts, and then generate a response that accurately addresses the question's core intent. So let's give an example of this. Let's say a user asks, what is postpartum depression? The query is broken down into smaller units called tokens. These tokens can be words, parts of words, or punctuation. The model uses an attention mechanism to weigh the importance of each token in the context of the others. In relation to chatbots, the multi-layer structure of the transformer truly enables this iterative refinement of each text interpretation. So each layer builds upon the previous one, which enhances the model's ability to discern meaning and context. This layered approach, combined with the model's large scale, equips ChatGPT with this extraordinary capability to handle this wide array of conversational scenarios, from simple question and answers to intricate discussions on various topics. The largest model of GPT 3.5 has 175 billion parameters spread across 96 layers in the neural network, making it one of the largest deep learning models ever created. In fact, it was trained on hundreds of billions of words. To break it down even further, self-attention allows a transformer model to attend to different parts of the same input sequence, while attention allows a transformer model to attend to different parts of another sequence. You can see in this example that GPT 3.5 is able to extract data from the same conversation. This is an example of attention. Neural networks are the cornerstone of GPT 3.5's ability to process and generate language. These networks, mirroring the complexity of the human brain, consist of interconnected nodes, or neurons, that work together to identify patterns in data. Each neuron in a network processes a small piece of the puzzle, and then when they combine together, they provide this comprehensive understanding of complex language structures. So in the context of GPT 3.5, these neural networks have been trained on an extensive data set, encompassing this broad spectrum of language use cases from everyday conversations to different specialized topics. This training involved feeding the networks a variety of text inputs and then teaching them to predict the most likely next word in a sequence. Over time, this process, known as unsupervised learning, enables GPT 3.5 to generate coherent and contextually appropriate responses. What sets GPT 3.5 apart is the scale of its neural network. With an immense number of parameters, it can capture subtle nuances in languages, making it this ideal backbone for sophisticated applications like ChatGPT. This vast network allows ChatGPT to truly understand user inputs or queries in different contexts and then provide responses that are not just accurate, but also relevant and personalized. After learning about the architecture behind ChatGPT 3.5, I decided to create an AI language model that assists new mothers and acts as a trusted companion. Let's see the model in action. So I asked the model how much sleep should a new mother be getting. Not only does it give actionable numbers, but it provides expert recommendations, the why behind the recommendation, and words of encouragement. Let's dive deeper into how GPT 3.5 is harnessed in Python for this custom chatbot. Our script's journey starts with importing two pivotal libraries. First, OpenAI, which is our bridge to the GPT 3.5 model, which allows us to tap into its advanced language processing powers. Then we bring in Gradio, which is a tool that is going to make our chatbot not just functional, but also user-friendly and interactive. It's kind of like setting up the stage and then also the microphone for performance. Next up, we feed our script with a dataset. Loaded from a JSON file, this isn't just any dataset. It's basically the script's playbook filled with predefined intents and patterns specifically curated for new mothers. These intents are like conversational starters, guiding our chatbot on how to respond to various queries or questions. Each tag in our dataset represents a topic such as breastfeeding challenges or postpartum nutrition. And under each tag, we have patterns and responses. Patterns are potential questions or concerns a new mom might have, like, why is breastfeeding painful? Responses are the chatbot's lines informed and these empathetic answers that are based on scientific data and studies. This dataset is the brain of our chatbot, enabling it to provide accurate and helpful advice. After setting the stage with our dataset, we enter the realm of GPT 3.5 by setting up the OpenAI API key. This key is like a VIP pass, granting us exclusive access to the capabilities of GPT 3.5. Now, the heart of the script is the custom ChatGPT function. This is where the magic all basically happens. When a user inputs a question, our chatbot basically plays detective and scans through the patterns in our dataset. If it finds a match, it's like hitting the jackpot. It immediately responds with a pre-formulated answer, which ensures the advice is tailored and relevant. But if there is no match, that's where GPT 3.5 comes in. Our script hands over the baton to GPT 3.5, which generates a response on the fly. This basically makes sure that even for questions that are not directly covered in our dataset, the user still gets some sort of coherent and contextually appropriate reply. Finally, we bring our chatbot to life with Gradio. This tool builds a sleek interface, transforming our script from a backstage setup to a live show. Users can type in their questions and watch as the chatbot, powered by our dataset in GPT 3.5, responds in real time. It's a demonstration of AI's ability to perform empathetic, informative, and this overall support to new mothers. And it's backed by scientific knowledge and the nuanced understanding of human language courtesy of GPT 3.5. This chatbot's potential to transform postpartum care lies in its ability to provide instant, reliable, and personalized support. For new mothers, having a resource that offers advice based on scientific studies anytime and anywhere can be incredibly empowering. It also alleviates the pressure on healthcare systems by providing first-line support, allowing professionals to focus on different cases. With further specialization and integration of more comprehensive data, this chatbot can evolve into an even more meaningful tool. Imagine a chatbot that not only answers questions, but also provided care plans, tracks progress, and even connects mothers with these different local support groups or healthcare providers. The possibilities are truly endless, and the impact on postpartum care could be completely profound. My plan for this digital platform is to enable users to log and track various health metrics, such as sleep patterns, hydration, and emotional states, basically creating a digital diary of their postpartum journey. This continuous tracking provides valuable insights into their well-being, highlighting patterns that could indicate a deeper issue like postpartum depression. But more than a tracking tool, I want to combine the built AI chatbot to simulate supportive conversations, much like those with a trusted friend. I want to program a feature that initiates check-ins, offers words of encouragement, and provides gentle reminders for self-care activities, contributing to the user's emotional well-being. By utilizing artificial intelligence, this platform transcends the limitation of traditional methods. It eliminates the needs for scheduling appointments, thus eradicating any associated stigmas of seeking help. The AI chatbot component allows for anonymity and a judgment-free experience, empowering mothers to open up about their struggles. By identifying trends in the data, it can suggest when a user may need to seek further help, which bridges the gap between technology and traditional healthcare services. GPT 3.5 represents a significant leap in AI language processing. Its transformer architecture, coupled with sophisticated neural networks, enables it to understand and generate text with a level of complexity and nuance that was previously completely unattainable. By implementing GPT 3.5 in Python, we can create powerful applications like this chatbot, showing the practical and versatile nature of this technology as a whole.